Hello everyone and welcome to MV Tutors. I'm Tolo and I'm going to introduce you to this lovely simulator website that will help you, especially with the topic for electric circuits. I used to struggle with them at high school or in high school. If a circuit has been given and then scenarios change, like we have here, where a fourth resistor is added or connected parallel to the 4 ohm resistor. Now I need to work out what's happening in here. I think this will actually help you guys to understand better. So whether you're in grade 10, 11 or 12, please do visit the Phet website so that it can help you understand better the electric circuits. There's more to it, like it's here saying it's a free science and math simulations for teaching STEM topics, including physics, chemistry, biology, and math, right? So we are thankful for the University of Colorado Boulder. Now let's go there. And once we enter, we want to go to simulations, right? And we're looking at physics. And once we are there, we're going to go search for a circuit, an electric circuit. So here it says construct or circuit construction kit AC, and then you'll have circuit construction kit, the AC virtual lab. Let's not go to the virtual lab. Let's rather go to the construction kit. And once you are there, just press on the play button and it will take you to an empty sheet where you can go and construct what we are seeing on the right hand side. Okay, the circuit that we have there. So just to zoom in, we have the wire, we have the battery, the AC voltage, light bulb. Then we have, oh my gosh, what did I do? I'm going to have to delete these things. Then we have the resistor and we have a switch. So the circuit that we have at the moment, it's quite straightforward. So we're not really going to do anything hectic. Let me just remove what we don't need there. And we're going to start with the wire. Okay, so what you do, you're going to have to click on the wire and press and hold. Okay, don't just click on it and think it will get there. You need to click and hold. Okay, so now what I'm going to do now, I'm just going to make it a bit longer. All right, and then I'm going to add a battery again, hold. All right, and then add another wire. And let's just make it a little bit longer. Okay, so still gonna have another wire. Okay, I'm just constructing it over there. Let's see how it goes. Add another wire. Then I'm gonna add a resistor. Okay, this resistor, I'm gonna click on it. Make sure that it's a 4 ohm resistor. So let's just go back down. 8, 7, 6, 5. Almost there. So we have 4. Okay, and then we're gonna add another wire. Ooh, we're gonna add another wire. Okay, what am I doing here? Let's add a wire. The screen is a little bit tiny. My fingers are big. Okay, we have a wire. I'm gonna add another resistor. Okay, that resistor is an 8 ohm resistor. So let's do it. Okay, there we are. 8 ohm. Okay, great. Let's add another wire. Okay, let's stick there. Okay, let's extend it over there. And another wire. So we're just gonna pull it there. Whew. And you can see we have a working circuit. Is the electrons, are they flowing proper? Yes, they are flowing. We can see it's going actually anti-clockwise, right? That's how it should flow. Now I'm gonna put in the 10 ohm resistor. So again, another wire. So there we go. It needs to attach over there. There we are. Okay, and then another wire. So there we are. Then I'm going to add a resistor. And that's the 10 ohm resistor. Okay, let me just... Ooh, resistor. Oh my gosh. Okay. It's going to be at angles there. Is it connecting? Yes, it is. It's connecting. It looks weird, but it's working nonetheless. So we have our 10 ohm resistor. I also, yeah, so we're almost there. I'm just going to put an ammeter there so that I can read what the current is at the moment. And let's see. Okay, so we can see the current flowing through the circuit is 1,07 amperes. All right, let's go to the question because I haven't even read what the question wants. So it says, 3 resistors are connected in a circuit as shown in the diagram below. Now a 4th resistor is connected parallel to the 4 ohm resistor. Okay, so compared to the original circuit, how will the power dissipated by the 8 ohm and the 4 ohm resistors change? Now you know power is voltage, or the voltmeter, or V multiplied by I, right? So we can already read the current in the circuit is 1,07. Once it gets to the first resistor, okay, as it flows, it's going to split, right? Because we have resistors in parallel. And then it's going to join again, 1,07 flowing through the 4 ohm resistor. So let's see what the voltmeter reading is across the 4 ohm resistor. Okay, let me just put this there. Now let us get to reading. Okay, so we have 4,26 volts going through the 4 ohm resistor. Please just make note of that somewhere. And what about the parallel connection? What do we have there? So we have 4,74. Alrighty. Okay. Now the current flowing through there. Okay, just remind ourselves. So this is 4,74. And this is 4,26. What happens if we just add a 4th resistor parallel to the 4 ohm resistor? Let me just put this over there. Put this to the side. Okay, let's add another wire so that we can have a parallel connection. Another wire there. What I'm predicting is as soon as we have a resistor in parallel, remember when the resistor is just alone there, the 4 ohm resistor, the full current will pass through. If the full current passes through, the power reading will be a certain reading, right? Now, if we add a resistor in parallel, the current will be divided. So I'm expecting for the 4 ohm resistor, the power to actually decrease. Okay, and if it decreases, we are left with option A as well as D. But what I'm uncertain about is what's going to happen to that 8 ohm resistor, because we need to ask ourselves what will happen overall to the total resistance. The total resistance, external resistance, will actually decrease as soon as you have parallel connections. And if the resistance decreases, our current, because it's inversely proportional to resistance, it will increase. Okay, and according to our formula, P is equal to VI, I am expecting if the current is increasing, the power will increase. So therefore, D is my option. Okay, but let us see. Remember our voltage reading there by the 4 ohm resistor was 4,2 something. And across the parallel connection, it was 4,6 something. So let's add another resistor. Okay, and then let's see what's going to happen. So I'm adding a resistor there. Let's just connect it. Ooh, let me zoom in because my fingers are big. Ah, goodness. There we are. All right, now let's read. Remember, before the parallel connection, we had 4, something voltage. Now it's happening to the voltage. Now we have 3,52. So if the voltage decreases, remember P is equal to VI. If the voltage is going to decrease, then our power will decrease as well. But do you see what happened to the current? Previously, the current was 1,07, if I'm not mistaken, right? Now it has increased, okay? So we are expecting the power across the 8 ohm and 10 ohm parallel connection to actually increase over there. But let's see the voltmeter reading. So you see voltage there has increased. We went from 4 comma something to 5 comma something. Okay, so power across the 8 ohm resistor would have increased, but power across the 4 ohm resistor has decreased. And that is how the simulation actually helps you understand circuits way better. Matriculants, grade 11s, grade 10s, while you still have the time now in preparation for your final exams, please acquaint yourself with this website. It's free. Please use it to your advantage to understand these electric circuits much better. All right, that's it from me. Bye. Okay, how do I switch this off?